In order to determine if like an ordered pair is a solution to an inequality like this, all you have to do is take each of these points. So pretty much just like you do any problem when they say check if it's a solution, take each x and y value and substitute it into your inequality. And all you got to do is check if it's true or false. If you get a true statement, it's a solution. And if it's false, it's not a solution. So let me show you what I mean. So I'm going to take the first point, 0, -2. So 0, -2, and don't forget, and you can see here in the table, x is first, y is second. If you ever get them mixed up, just think alphabetical order, x first, y second. Then I'm just going to rewrite this inequality a little bit bigger so you can see it better. And what's important is you got to understand what the symbols mean here. So as a little quick reminder, this one here means less than, this is more than, less than or equal to, greater than or equal to. So I'm going to go ahead and take my x value and replace it for x. So x is 0, put parentheses. When I substitute, replace the y, which is -2. So I put a -2. And you can see I substituted my x and y values there. Next step is to simplify using order of operations. So notice on the left side here, it's just a -12. We can't do anything with that. All the work is going to happen over here where we have to simplify. So we have addition, multiplication. We multiply first. So I get 0 plus, and if I multiply those, -12. And don't forget that 0 plus -12 is -12. So you can see here, we have -12 is less than or equal to -12. So keep in mind, this actually is a combination of two things. So what this is really saying is this. So it's two problems in one. So I'm going to rewrite it. So again, when you see less than or equal to, they're combining, this is combining this and this. So it's this or less than or equal to combined into one symbol. So in order for this to be a solution, the point 0, -2, we just got to check if this is true or false. So is -12 less than -12? No, that's false. Or is -12 equal to -12? That's actually correct. So it only has to be true for one. It doesn't have to be less than, but it could be equal. So as long as it's true for one, it's a solution. And in this case, it is true for one of them. So I'm going to put yes, it is a solution. And now I'm going to do one more example, the one with the point -6 and 5. So I'm going to use that point. Again, this is my x and my y. I'm going to rewrite the inequality. 2x plus 6y less than or equal to -12. Then I'm going to substitute. So 2 in place of x is -6. In place of y is +5. So always be very careful with the negatives. So now, same thing, multiply this, I get -12, plus multiply that, I get 30. Again, nothing's happening on the right side because this is a single number. So now when I add these up, I'm going to get +18 less than or equal to -12. And again, it means two things. This is saying is 18 is either has to be less than -12, which is not true, or it has to be equal to 12, which is also not true. Therefore, it's not true for either one. So I go back to my problem and I put no, this is not a solution because you get a false in either case. So again, you're basically looking for yes, it's a solution is if you get a true statement like we did over here, where it has to be true for at least one of those cases, and then it's not a solution if it's false for both. But again, you're only looking to be a solution. Always has to be true, whatever inequality you're dealing with. And if you get something that's false, it's no.